continue our discussion on inequalities, and we're going to start with this problem that Chang has at most $60 to spend on socks and sneakers. He finds a pair of sneakers that he likes for $36. If the socks are $3 per pair, how many pairs of socks could Chang buy? The first thing we're going to do is model it with a block diagram, and from that block diagram we'll write an equation. So we're going to look at the price of the sneakers and the socks combined have to be less than $60. Must be $60 or less tells us that this is an inequality because it doesn't say it has to be exactly $60. So we'll start with our block diagram and the price of the sneakers plus three times a pair of socks, because 3 times P for the pair of socks, because each pair of socks is $3, and must be $60 or less, because that's all the money he has. Must be less than or equal to $60 would give us a less than or equal to sign. So in this spot right here, down here, we'll have 36 plus 3P and the less than or equal to sign, and $60. Now, algebraically, we would do that. Algebraically, we would do that by writing the equation 36 plus 3P is less than or equal to 60. Now, we know that whatever's being done to our variable, we have to undo it. And we undo it from the least important to the most important. So right now, the least important thing that's being done is we're adding 36. So we need to subtract 36 from both sides. That's going to be done right here and right here. And when we do that, that will leave us 3P is less than or equal to 24. Once we're at this point, what's being done now is multiplication, and we can divide by 3 on both sides to maintain that balance, and P will be less than or equal to 8. Remember, we could always still set up our do-undo chart. We have do, undo, all right? What's being done, multiplication times 3, and addition plus 36. We undo that in reverse order with the reverse operation. We get minus 36, and we do divide by 3. And as you can see, that's the steps they took, all right? Now, once we get the answer, we need to we're going to model our solution set on a number line. Notice that we said P is less than or equal to 8. So we're going to mark all these spots where we have P. We have right here at 8, we have right here at 7, 6, 5, 4, 3, 2, 1, and he could decide not to buy any socks at all, so 0. Notice that we do not have an arrow pointing in this direction. There's a reason for that, because in this particular set, only the whole numbers are solutions. You can't buy a half a pair of socks. You can't buy 3.5 pairs of socks. So with that in mind, then we know that our solution set contains only the whole numbers. So if we go back and look, we want to look at the inequality statement and model. What does that inequality statement mean? That inequality statement means that we are going to buy some shoes, right? We're going to buy these shoes, and the cost of the sneakers plus the cost of the socks has to be less than $60. So this inequality statement means that the cost of the shoes and the cost of the socks must be less than or equal to $60. Right. So the steps for solving this inequality using the terms constant and coefficient. So we need to list those steps. So step one was to subtract the constant from both sides. Step two was to divide. Let's fix that. Step two was divide both sides by the coefficient of the variable. All right. And the next question says, explain why the numbers between each whole number are not a part of the solution set. That's simply because you can't buy a half a pair of socks. So we can't buy half pairs of socks. Okay? And according to the graph, what is a complete solution set? So you write that, you do a braces, right? And then you just list the numbers with commas between them. And then close with another brace. So our solution set, according to the graph, is 0, 1, 2, 3, 4, 5, 6, 7, 8. The next question says, why are -1 and -2 not part of the solution set, even though -1 is on the graph? The reason for that is simply that you can't buy negative pairs of socks either, right? So, all right, so we're going to have to scroll up and then erase this so we can finish this up. So we'll do that. It says, how do you graph the solution set of an inequality when the set includes only whole numbers? Well, we saw that on our graph, place a dot, a closed dot, by the way, a closed dot on each whole number that is part of the solution set. All right, we should have that. Now we're going to look at the try it section. Try it, we're going to use what we learned about these inequalities to solve these problems and show your work on a separate piece of paper, and then I'll collect that on Wednesday. Right, students in the garden club are planting a spring flower garden in the town square. They have already spent $80 of the $200 budget. Write and solve an inequality to show how many $30 packs of bulbs they can buy. So they've already spent $80, right? So whatever they spend for the bulbs is $30. Well, I don't want to use red because it's hard to see on the camera. $30 times the pack of bulbs, so let's put that B, right? Plus 80 has to be less than or equal to 200, right? Now it says solve that. To solve that, we'll take 80 from both sides, and that'll give us 30 bulbs. 30 times B is less than or equal to 120, right? Then we divide by 30. Divide by 30, and we'll get B is less than or equal to 4. Now our number line for that, I'm just going to draw it up above it and make it easier. Our number line for that is going to be like this. We'll put 0 over here. 1, 2, 3, and 4. Put 5 there. And then we'll put a dot at each one that we do, less or equal to 4. So we'll go here, 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 and here. So they could buy 0, 1, 2, 3, 4, or 5. And if we were going to draw that solution set out, it would be 0, 1, 2, 3, and 4. And that would be read as the set consisting of 0, 1, 2, 3, 4. Alright, so you can run this film back and forth as much as you need to in order to get your workbook completed. Your homework for tonight is page 173 and 174, and I will see you tomorrow morning.